Hi viewer, welcome to EasyElimu channel. I'm Vincent Kanmoy and today I'll be taking you through Form 2 Mathematics. Today I shall be handling the topic of area of triangles. Stay tuned as I welcome you all. Now I shall be handling area of triangles given two sides and one of the angles. Here, we normally know from our previous session that area of a triangle can be given by a half base height, which means is a half times base times height, whereby B here is representing what I am referring to base and H represents height. And this normally deals with a right angle triangle together with any of the triangles which have height, for instance isosceles or equilateral triangle. For instance, given a triangle which is a right angle, for example this one, and you may be given this side as 4 and let's say this side as 8. To find the area of this triangle here, you will take a half multiplied by base. Here the base of this triangle will depend on which side it lies on the ground. For example, for this case, the horizontal line here will represent our base. So that is 8, and then the height here is the line which is away from the horizontal one, so it will be 4. And on doing that, we are going to have 2 here, 1, 2, 2, 2 multiplied by 8, you will get is 16 square centimeter. So that is what we shall have as the area of that triangle. For instance, if you have that isosceles triangle, for example, this side here, you are being given this side is 16 centimeter. So you are being told to find the area of that triangle. So since we have said the area is a half base times height, so we shall evaluate a half, but the base here now will be 16 because that is the horizontal line. But remember the height here, you will have to divide it or to divide the angle, the upper angle into 2, which divides the two equal sides, and you will find on dividing that you will find these angles being the same, and you will have created two equal right angled triangle. And for that case, you can also divide this side and find that line will divide the bottom line into 2, making you to have two equal sides of 8 centimeter each. So meaning you can use one of the right angle triangle here, which now here I will refer to as this. I will take this one with the hypotenuse 10 centimeter and the base, which is now the adjacent or the opposite to be the adjacent here to be 8 centimeter, and now the height of this one will be equal to 10 squared minus 8 squared, as we saw in Pythagoras theorem. So on doing that, we shall find 10 squared minus 8 squared, and finding the square root, you will find that this one here will give you 6 centimeters. That is 100 minus 64, you will get that 6, square root of that 6 is 6. So we shall multiply by 6. And on doing that, we are going to find, here you will find it is 8, and on multiplying you are going to get the area of that one is 48 square centimeter. That is how we can find the areas of given triangle, definite triangles. So that is how we use that formula. But for some instance, you may find some situation arise in that you cannot use that formula to find the area of a given triangle. And those situations may arise if you may be given two sides of that triangle and one angle included, and in that you cannot find the height, or if you find the height is not a definite height. For that case, you may have a side as, for example, let's take you have a side like this angle you are being issued as 30 degrees. This one here is 12 centimeter, and from B to C here, and this is A, you have it as, let me remove this because we shall insert. So we have it as 16 centimeter. and that one is 12. So you are being issued with that triangle ABC, and you are being asked to find the area of that triangle. One way you can still find it using the Pythagoras theorem, which we used earlier, by cutting this point here, and with that you can use that one and find out that from trigonometrical ratio we had 30 degrees and 12 centimeter, and we said we can still find here, because this line here is much more length, so we can not use it to find the other way. So we shall find by saying that if we find the sine of that angle, sine of 30 degrees, we shall find that the sine of this angle is equivalent to the opposite of that angle, which is a line which is from A, let's say this one is N, so A to N, over the other one is A to B, AB, because that is the hypotenuse to the angle. So that line A to N is simply representing our height. So if you want to find that height, then it will be sine 30 degrees is equivalent to AN, which we don't know, we can refer to as X. AB we have as 12. So meaning that if we need to find X, we shall multiply both sides by 12 so as to find the value of X. So on multiplying both sides by 12, we shall find our X equals to 12 multiplied by sine 30. And still you can use either the tables or you use calculator, but for our case here we shall be using tables, and we shall use natural tables, natural signs. Under the natural sign we shall find the sine of 30, and you will find that the sine of 30 is 0.5. You can either use natural tables, you can use natural signs under the tables or elementary, 4-figure elementary mathematical table, or you can use a triangle which was identical. So the identities are under the trigonometrical ratios, whereby you use a triangle with sides 1, 1 and root of 2, and you can still find what we are referring to this. So we shall find that this one is going to give us a half, or the sine of 30 is a half, or 0.5, as you can prefer. So that one will give you a 6 centimeters. So meaning the height here is 6 centimeters, and now you can use the area formula there, which we say the area of the triangle is a half base times height, and for our case our base here we are having a 16 and height we have found as 6. So on evaluating we shall have the same as we had found earlier. So we shall have the area of that triangle being the area of triangle ABC, we shall find it as 48 square centimeter. So that is what we have at that case. That's how we can evaluate it, if it is definite that you can find the height. But today I shall introduce you another way of finding it. Instead of just calculating through a tedious work, calculating the height, you can still use the two sides and one of the angle inclusive and find the area by applying one of the formula as here. So we can just simply say that the area of that triangle ABC, you can still find it by taking a half AB, whereby A there, AB sine theta. And here, A, where A and B are given sides. These are given sides which enclose a given angle of that triangle. For instance, here we are having this angle 30 degrees here being enclosed by two sides, one having 12 centimeter and another one 16 centimeter. Let's take out this 6 centimeter because it was not inclusive at that point. So if that is the case, then it means that here, if it is 30 degrees, this side can be A and this one can be B. And if you have that way, you can still find the area by taking that way, and you will have that the area of the triangle being a half multiply by A, which is 12, multiply by B, and B is 16, multiply by C, multiply by sine theta, and sine theta here is sine 30. So on doing that, using trigonometric ratio, we can find that sine 30 here is a half. So on doing that, we shall have a half multiplied by 12, multiplied by 16, multiplied by a half. Sine 30 is a half. So on doing that, we are having here is 6, here is 8. So this one is still giving you 48 square centimeter. So you have clearly seen that the two methods will give you the same answer, but the best way of calculating it is just involving a half AB sine theta. If you have been given one of the angle and two sides enclosing that angle, and that is a triangle. That is how we can use it to calculate. For your case now, I'll give you one of the triangle, and I need you to find the area. Now we have this triangle here with angle ABC 80 degrees, angle ACB 40 degrees, and denied angle BAC. And you have been given the side AB as 3.6 centimeter and AC as 7.4 centimeter. And here you are being required to find the area of that given triangle. Since I have told you, here we don't have height. And as you can see, this measurement here are different. And we are required, firstly, here, you will be required to find the angle in which the two sides or the two measurements of the sides you have been given enclose that angle. For this case, you shall now find this angle. That's the first hint. And that one I will help you. Since a triangle, if you add up the degrees in that triangle, it must be summing up to 180 degrees. So we shall subtract the one which are being issued here. So on doing that, you are going to find that the angle which is missing here is 180 degrees, subtract 120 degrees. And on doing that, you are going to find that this angle alone is 60 degrees. And from there, you can now use that because we have an angle and two sides given enclosing that angle. And you can now find the area of that given angle. So I will require you to find the angle at the area of that given triangle. In our next session, we shall see, in case we don't have the angles, but we have been issued with the whole sides, that is the measurement of those sides, how can we find the area of that given triangle? We have already seen how we can find the area of a given triangle in case we have been given two sides enclosing a given angle. Now we are going to see how we can find the area of a triangle given the three sides but denied the angles. In that case, you will have a triangle of a resemblance of this with the measurements A, B, C as A, B, and C as you can view there. So in case we have been given a triangle with three sides and the measurement of those three sides being issued, then you can either construct that one using a scale drawing, which is exact to measurement, then you evaluate or calculate the area of that given triangle. But still, if you don't want to construct that given triangle, you can still use Hero's formula to find the area of that given triangle. And Hero's formula is given by, that is Hero's formula. It is given by that the area of that triangle, for example, if it is triangle ABC, it is given by the square root of S into S minus A, S minus B, and then S minus C. All the written measurements there are under the bracket, whereby where S is equal to a half of the perimeter of that triangle, meaning that S is equal to a half A plus B plus C into bracket. So A plus B plus C are the sides of that given triangle, meaning that if you sum them together, you will be finding the perimeter of that given triangle. So if you find a half of it, you will be finding S. And here A, B, and C, A, B, C are sides of that triangle. As you can see there, the measurement. So in case you have it, you can use that formula to find the area of any three sides given triangle, so that you can find the area of that triangle. For instance, you may have a triangle such that this one, the same issue, but now A, B, C have been replaced by real values, which are in numerical figures, such that we have, this is 14 centimeter, this is 12 centimeter, and this is 17 centimeter. And we have been asked to find the area of that given triangle. To find the area here, first of all, you need to find S. And finding S, you need to find the perimeter of this triangle. And the perimeter here, we have said that to find the perimeter here, you will have to take A plus B plus C, of which here the A plus B plus C, A, B, C are the sides of that triangle and are given in terms of 14, 12, and 17 centimeters respectively. For this case now, we shall add them together and find out that we are going to get 43 centimeters, and this is the perimeter of that given triangle. So if that is the case, we can still find the area, whereby we are required first to find S. And finding S here, we said S is equal to a half the perimeter of that triangle. And the perimeter here we have obtained as 43 centimeters. So meaning that a half of 43, we are going to get it as 21.5. 21.5 centimeters. That is what we have as S. Now we can now find the area of that triangle by using Hero's formula, or you can still construct using the real measurement, but sometimes these measurements are too large to be occupied by your cover book, or to be occupied by the paper of your book. So you just advised to use Hero's formula, and using Hero's formula we shall find the square root of S, and S here is, we have found is 21.5 into, now here we shall start by S minus A, and A is 14, so it is 21.5 minus 14. Next is 21.5 minus 12. Next is 21.5 minus 17. Now, on evaluating, we are going to get, the first one will remain 21.5. Now we are removing the bracket. So on removing the bracket here, we shall remove it by cross multiplication sign. And on doing that, we are going to have 21.5 minus 14. We are going to find 7.5. The same apply to this one. 21.5 minus 12, we are going to get that one as 9.5. Then 21.5 minus 17, we shall find 4.5. Now we are going to multiply all what we have in the bracket, and then we find the square root of that one. And on doing that, we are going to have, this one will give us, so we are going to get, let's see what we find there. Now we are going to find that this one here is arising to 6,893.4375 square, actually centimeter raised to 4. But remember, we are still finding the square root because it is under the square root sign. And on doing that, we are going to find the value there will amount to 83.0 0.0267 to 4 decimal places, and this one is having square centimeter. That is the value which we have found using or after evaluating using Hero's formula. So we have seen that in case you are being given 3 sides of a triangle, may it be of any kind of a triangle, but you are being issued with the 3 sides of a triangle, you can use Hero's formula to evaluate the area of that given triangle as we have evaluated. First, you need to find S. After finding S, you use it in the Hero's formula. But remember, S is a half of the perimeter of that triangle. Then, after finding that, you can still find the angles of this triangle. And that angles, remember, you can use it, the first formula, to incorporate here. Since we have found the area is this, you can say that the first formula was area of a given triangle is equal to a half AB sine theta. So if you need this angle here, you can call it as theta and take the 2 sides as the enclosed sides, so that the 2 sides BA and B, and the area here be what you found here, so that you can use it to find the angle. And remember, if that's the case, you will say, for example, this case, you can take 14 and 217, so we can say 83.0267 is equal to now a half multiplied by 14 multiplied by 17 multiplied by sine theta, and theta here is an angle which I don't know and I'm seeking it. So if that is the case, we can evaluate it out and find that this one will be 7 by 17, and if you need sine theta, you will be required to divide both sides by 7 times 17 and also here by 7 times 17. And you will find that sine theta is equal to what you have here. So that if you want theta, you will have to find the sine inverse of the value you will have, and that will be the angle of that given enclosed angle. So the same applies to the angle ABC and BCA. So meaning that if you have been given 3 sides of a triangle, you can still find the area of that triangle, at the same time find the angle by using or incorporating the 2 formulas, both Hero's formula and the sine formula, as we have seen. With that, we have come to the end of our topic today. I believe the lesson has been interesting. See you in our next videos.